What is up, AP Stats? Here we go. We are on our Q&A session today, and I'm going to get us set up. I know I'm kind of a little bit behind. Got some cool things going on. I've got my projector popping over there, and then, hey, do you want to say hi?
Hi.
What you doing?
I'm playing.
You're playing. What are you playing with?
Papers.
Papers? There you go. So we are doing everything today on this Cyber Day. Hopefully you're having a good Cyber Day. Hopefully it's not too much work today, and we'll be underway. What's up, baby? And we're doing a podcast right now. It's for my students. Oh, you want to come and sit? All right, come on, come and sit. You can kind of say hey. All right, so as we go through this, I do want to see here. Let's go here. I'm going to kind of pull this up. All right, let me pull up the podcast here. Let me kind of pause that here. All righty, let's do this. All right, I've got that underway. Hey, if you've got questions, put them on the right. I know Lindsay had texted me earlier about a specific question. Sweet, Harry, good to see you. Yeah, here we go. I'm going to kind of have those questions on the side. So simply post those questions on the chat, and I'll go through those there, okay? All right, so let's do this. Let's start by going over the one over the FRQ on HW 8.1. Pull that up here. And as I do, I'm just going to take a screenshot of this. Let's see here. Yeah. Let's see. Pull this up. What's going on again? Any questions you have from 8.1 to 8.3? This is kind of like a review session. Hopefully it will be helpful for you today as we go through those. All right, let's see if we can do this. Post this right here. All right, I'm putting it over on this side. So I'm going to start with this FRQ, try to go over each of the specifics, and then kind of hit it and go, okay? All right, baby. Hey, I'm going to put you down, okay? Because we're going to put you off. All right, have fun. Have some fun play. All right, so couple things when I go to this FRQ that we're looking at. It says to increase the business, the owner of a restaurant is running which customer. Okay, that's fine. You don't have to play. In which a customer's bill can be randomly selected to receive a discount. The program was written to generate a discount with a probability of 0.2. That is giving a 20% of the bills a discount in the long run. However, the owner is concerned the program has a mistake that the results did not generate the long-term proportion of P equals 0.2. So 0.2 is really the ideal discount, right? But the question is it really promoting that discount? So it says consider this confidence interval. Does the confidence interval provide statistical evidence that the program is not working as intended? Well, if I were to add and subtract 0.06 from my, which is my margin of error from my point estimator, you would get 0.21 as my greater than, and my less than would be 0.09. Well, since 0.2 actually falls within this, it really, if you were to look at this for this sample, out of the 95%, the 0.2 falls within it, right? So the 0.2 is within it. Since 0.2 is within this, we do not have convincing evidence, okay? We do not have convincing evidence, and that's how we kind of started, that the program's not working as intended, since 0.2 falls within my 95% confidence interval. Now, the question on 2, and that just part of a little context here, does the confidence interval provide convincing statistical evidence that the program generates the discount with probability? Oh, hold up. Come back up here. Does the confidence interval provide statistical evidence that the program is not working as intended? Okay, selected a random sample and found that only 15% of them received a discount. Oh, we want 20% of them to get a discount. Okay, let me say. See, does confidence interval provide convincing statistical evidence that the program is not working as intended? Believe both of these are the same. generates the discount with a probability of 0.2. Okay, so yeah, this kind of talks about is it really working? The long run proportion of 0.2 is kind of where we're at. Let me look at this real quick. I do want to just check this out as we're looking at this problem. Just to see, I'm having a little bit of a concern in terms of what the difference is between 1 and 2, and maybe I'm just reading it crazy, which could happen. So we'll go to 2015 AP Statistics, problem 2, scoring rubric. Okay. So I'm just going to look at this real quick and just see where the scoring guidelines were as we look at question 1 and 2. And I want you to kind of look at this, just seeing the answers. I think, yeah, both of them are the same answer. I think they're just asking it in a different way. And I think that maybe that might have thrown some of y'all off as well. Because it looks here, it says, no, the confidence interval includes the value of 0.2. Therefore, it is plausible that the computer program is generating discounts with probability of 0.2. And the confidence interval does not provide, this is what we were saying, convincing statistical evidence that the program is not working as intended. Okay? Hey, baby, I'm on a podcast right now. This is live, okay? So if you need something, go up and see Mom, okay? All right, number 2. The answer is no, the confidence interval includes values from 0 or 0.09 to 0.21. So any value in that interval is a plausible value for the probability. Yeah, kind of the same thing on numbers, I and then II. I guess the first one's talking about the overarching program itself, and then 2 is more or less referring to is 0.2 plausible. And since it falls within our confidence interval, yes, that's a plausible value. Since we got that from our sample falls within our confidence interval. Now, the next thing is a second random sample of bills was taken that was 4 times the size of the, hold on, I'm going to get my wife. Abby's, I know, really loud. My apology. The beauty of having kids on Cyber Day. Gotta love it. Sorry about this. All right, we'll keep going. A second random sample of bills was taken that was 4 times the size of the original sample. In the second sample, 15% of the bills received the discount. Determine the value of the margin of error based on the second sample of bills that would be used to compute an interval for P with the same confidence level as that of the original interval. Well, as we looked up here, this up top, we didn't know what the confidence interval actually was, right? But what we did know that is that the margin of error was equal to 0.06. And as we looked at this, it also found that, well, it didn't give us what little n was, right? But it just said second sample was taken 4 times the size of the original. So we're just doing 4 times little n. In the second sample, 15% of the bills received the discount. Determine the value of the margin of error based on the second sample of bills that would be used to compute an interval for P with the same margin of error, okay? So basically this margin of error was 0.06, right? Which is Z star multiplied by P hat times 1 minus P hat divided by little n. Well, if we multiplied by 4 here, what we're going to be doing is we're going to be multiplying this bottom part. Hey, baby, please be quiet. Hey, keep it down, okay? All right. Thank you, babe. So we're going to put 4 and multiply 4 times our sample size of n. So what we're going to have is everything stays the same, except we're multiplying this by 1 over the square root of, we did the square root of n. We're going to multiply by the square root of 4, 1 over the square root of 4. So what stays the same? Little n, P hat, and Z star. The only difference is we're multiplying it by 4. So we could expect to multiply the margin of error, whatever that is, by 1 over square root of 4, right? Because that's the only thing right here that changes. Well, what's the square root of 4? That's 2. So we're really multiplying by 1/2 here times 0.03, which is 0.03, right? Again, 0.03 is smaller than 0.06 in large part because it's a larger sample size, right? So we would expect the margin of error to be smaller at 0.03. Now C says, based on the margin of error that was obtained, what do you conclude about whether the program is working as intended? Well, now we've got the same 0.15 point estimator, but we're adding and subtracting 0.03, which gets me 0.12 to 0.18. And at this point, since 0.20 falls outside of this, we do have convincing evidence based upon our results that the program is not working since 0.20 falls outside of our 95% confidence interval. And so that's what we would state because, again, just falling outside of our interval here, okay? Good stuff. Very good. Great question there, Lindsay. Good work there. I'm looking at any of the stuff that we have on our GroupMe. And then also checking out the online. Let's see here. Awesome. All right, good. Yeah, let me go over the bias question on the quiz. That's a really good one. So as we looked at bias, we remembered that this idea of, let me actually do this with this. Let's get rid of that. Okay, so we talked about with bias, this idea of what happens with my confidence interval as my sample size increases, my confidence interval will decrease, right? You say, why? Why is that, coach? Because the variability decreases, right? As variability decreases, we can have, with everything being the same, the confidence interval will decrease. If our confidence level, you say from 90 to 95%, if the confidence level goes up, what we can say is that if we have higher confidence, then my confidence interval, the actual interval itself, will actually increase, okay? Think about it. If we want to be more confident, we want to make sure with everything being the same, if my interval was from here to here for a 90%, if I want to be more confident at 95%, the interval from here to here would have to actually increase to have more confidence that it captures my true mean or true proportion, right? And then so that was like the second thing. This was the first thing. The third thing talked about bias, right? Well, we remember that bias comes not as a result of the actual sample size, right? That has nothing to do with it. It actually also doesn't matter the confidence level, whether it's 90 or 95%. It all records, it's all based upon how am I sampling, okay? All right, so if I sample in an appropriate way, is it representative, good representation of my population? That's really the question, okay? If so, then we have low bias. But if we have something like where we have non-response, right? Or it's not random, okay? Or we have, I was trying to think of something else. Non-response, under coverage, right? All of these things are not even based off of the sample size or confidence level, right? So bias is not, we're not really talking about bias in terms of what will increase the confidence interval here. Really, bias is based on solely how am I sampling. So because it's based off this, and whether it's representative of the population, and whether we decrease the various forms of bias, that is how we decrease bias, not by confidence level or sample size. Because think about it, if I have a bad sample, right? Let's just say this is a bad sample over here, okay? If I sample 10 people compared to 100 people, it's still gonna have bias, right? Like, yeah, will this have less variability? Yes, we'll have less variability. But it still is going to be biased and not be a good representation of my population, whether I have a high sample size or not. Same thing with 90 to 95%. Yeah, if I want to be more confident, this is going to have a wider interval than 90%. But it's still going to have bias because I sampled poorly. So it's not based on sample size or confidence level, simply it's based on my sample. How did I actually sample? Okay. It's a good question, Ryan. Hope that helped. Hope that helped there. 8.2 questions. Yeah, we can do that, Harry. Throw those out there. Perfect. Good. Yeah. So if you guys have questions specific, go ahead and throw those out there. Hannah, let me go ahead to your 96%. And Harry, when you say 8.2 questions, just throw something specific out there, okay? All right, let's talk about 96%. If this is a 96%, let me actually do this. Let me get my calculator out here while that's going. So if this is 96%, what we notice is that the actual tails include 0.02, right? That's like the area on either tail. When we go to either inverse norm or table A, we would go there and we look on the inside for the area of 0.02, right? That's basically the goal. So that's the idea there. So that's table A, 0.02. You could also go to your calculator and go to inverse norm. And what you would do is put area, mean, and standard deviation. Since we're talking about Z star here, we want to make sure that the mean is 1, standard deviation 0. And my area would simply be 0.02. That's to the left of this. And what happens is when you put it in as 0 or 1, 0, this allows me to see what the standardized value is or what the Z star value is. So if I did this inverse norm of 0.02, or if I went to table A, I would go and I'm just using my calculator here. But if I went to second vars and went down to inverse norm, second vars, inverse norm, I would make sure, hold up, let me get out of that. Second vars, there we are. Inverse norm, area is 0.02, mean, standard deviation 0, 1. I think I said 1, 0, I'm sorry. Should be sigma. I'm sorry, this is mean, standard deviation. This should be 0, 1. My apology. Standard deviation is 1. Can't have a standard deviation of 0 there. So once I plug this in, I would get a value of negative 2.05. Negative 2.05, which would be both to the left, positive or negative 2.05, and then to the right, positive 0.205. Okay, and so and this would be actually our point estimator, which would be x bar p hat right in the middle. Okay, so again, we're just trying to figure what is the Z star. It would be plus and minus 2.05, and you could just put the positive version of that because it's built into the actual equation. All right. Good stuff. That was a good question, Hannah. Great job there. Next question. Multiple choice on 8.2. I can definitely do that. Again, Harry, if you've got questions on that 8.2 stuff, go ahead and throw that out. We definitely go through that together. All right, let's see here. 8.2, HW 8.2. And I will pull this up. Hope you're having a great Cyber Day today. Hope you're enjoying the snow outside. No, I'm just joking. It's not really snow, right? Alrighty. Hopefully you enjoyed that podcast too. I was kind of crazy last night. It was kind of a little late. So I apologize if I got a little carried away. But yeah, you know, we have fun in AP Stat because we are AP Stat. We are AP Stat. Sorry, I'm throwing these multiple choice over here. This is a filler. It's a filler. All right. Cool. We'll do this, this, and this. All right. Let's go over the questions. Number 49. It says a Gallup poll found that 98% of American adults expect to inherit money. The poll's margin of error was plus or minus 3 percentage points at a 95% confidence interval. So 0.28, my point estimator. Plus or minus 0.03, right? So this would be about 0.25 to 0.31, right? If I added and subtracted. So if at a 95% confidence interval, we would say the poll used a method that gets an answer within 3% of the truth of about the population 95% of the time. The percent of all adults who expect an inheritance is between, well, that's not guaranteed, right? We're 95% confident, so let's throw that one out. C says if the Gallup takes another poll on this issue, the results of this second poll will lie between, well, we may not know that because each sample varies. D, there's 95% chance that the percent of all adults who expect an inheritance is between. That sounds really good. That's a good interpretation. A is the poll used a method that gets an answer within 3% of the truth about the population. This, I could kind of see A. It's just not a great answer. D is like the answer that we talk about within an interval, right? Gallup can be 95% that between 25%, 31%, the same one. Like here. Yeah, we can't. Yeah, this is of the sample. That's not true. Really, it comes back to D. D is the answer there. That's the definition of interval, confidence interval. 50, most people can roll their tongues, but many cannot. I don't know if you can. I can not. The ability to roll the tongue is genetically determined. Suppose we're interested in determining what proportion of students can roll the tongue. We test an SRS of 400 students and find 317 can roll their tongue. So 317 out of 400 can, right? The margin of error for a 95% confidence interval among students is closest to, well, this would be margin of error would be Z star times P hat times 1 minus P hat all over little n. We did a total of 400 students, so 400 would be on the bottom. P hat would be on the top. So 317 divided by 400 would be 0.79, or it's about 0.80 times 0.20. Z star for 95% would be 1.96. And this is just calculator stuff. So just plugging it in, getting it out. And I'm just getting it here and multiplying by 1.96. I got 0.0392. 0.0392. I got 0.04 as the closest one as the answer there. 51, you want to design a study to estimate the proportion of students at your school who agree with the statement. The student government's an effective organization for expressing the needs of students and administration. You will use a 95% confidence interval. You'd like the margin of error to be 0.05. The minimum sample size required is, well, margin of error is this or less, so we're going to use 0.05. And we're going to set it equal to our Z star times P hat times 1 minus P hat all over n, right? Where little n is our answer because that's our sample size. 95% confidence is 1.96. Okay, so we're going to set it there. 0.5 is our P hat. That's that conservative value if they didn't give it to us. They didn't really express what that could be. So we're just going to leave it as 0.5. That's there just to be conservative because that will produce the highest sample size possible. So we will do that. So we'll do 0.05 divided by 1.96. We'll square both sides. And then we'll take that value of, and once I square it, I get 0.25 over n equals 6.508 times 10 to the negative fourth. So I'll divide this. Really, we can just switch these two. This divided by 6.508. So we'll do 0.25 divided by that to get 384.16, which just rounds to 385. Okay. Awesome. So it'd be C. 52, a newspaper reporter asks an SRS of 100. Okay, 100 here for their opinion. Using the results from the sample, the C percent confidence interval for the proportion of all residents in the city who approve of the city's job performance is this. What is the value of C? What percentage? Ooh, that's pretty good. Okay, so first off, this is my interval, 0.565, 0.695. So what's my point estimator? Well, we could kind of figure this out by saying, okay, all right, so if we did this, we could just divide this by 2, or Adam divide by 2 to find that middle value. Divide that by 2. So the middle value here is 0.63, and my So this would be like p hat. And my mo would be just subtract 0.63 minus 0.565, just because it's plus or minus. So it's adding and subtracting 0.065, okay? So the question is what is the C percentage? And knowing that you have all of these details that are here. Well, 0.065 is our margin of error. So let's do this. It says the C percentage. See what it says. So we want to point. Question is like 0.63 is our p hat. Okay, so we're gonna say we're gonna set this up here. I'm gonna erase this down here. I was looking at this. We know our mo, right? So we would say, okay, so this is 0.065 is equal to z star times square root of p hat times 1 minus p hat all over little n. We know that 100 is on the bottom, and we know p hat, because we're estimating using p hat, is 0.63 times 0.37. The question is what is z star? Okay, that's our question. And we could find this by simply doing 0.63 times 0.37 divided by 100, and then taking that square root of that value. Okay, I got 0.0483 right here, and then I'm going to divide it over to this side. So 0.0483 divided over, which was this, right? To get z star by itself. So 0.065 divided by that to get, and I got a z star is equal to 1.346. So the area that is to the left of this is going to help me, right? But the z star means that that's the amount of standard deviations to the left and to the right of my mean. So I'm looking and seeing at 82, 86, 90, 95, 99 on table A, where is the z-score 1.343. So let's go over here. Let's go to table A, statistics. Go to my formula sheet, go to table A. And again, we're using table A mainly because we're focusing on proportion world, right? So we'll actually do the opposite. We know the z-score is 1.34. So we're going to go to 1.34. So I got a area, and you could do minus or plus. Let's do minus 1.34. So I got 0.0918. 0.0918. So as we look at this area is 0.0918, and that would be on both sides. So if I were to add these together, it's approximately 10 on each side. It's closest to that. So we would say that the confidence interval, 10 on either side. Oh, hold up. Actually, no, back up. I was thinking both. If I have 9 on either side, right? 9 plus 9 is 18, which means we're closest to 82% in the middle. And that's how we would get A. My apology there. I was thinking 1 and not both sides, right? And that's how we would find that value. That's how we would attack it, okay? Good stuff. Okay. Here we go. Can we do 8.2, question 43? Yeah, let's do it. Kind of erase this and clear objects there. We're going to clear everything. There we are. All right, HW 8.2 again. Question 47, I believe. I think it was. So question 47? I think that's right. Let me just double check. As we pull it up here, 43, question 43. Or hey, do you want 53 or 43 there? Harry? Any thoughts on that? With 53, I don't know, we didn't do that one yet, did we? 53. Oh, that's the FRQ. We could pull that up. Let's see one more time. 43. Is there a 43 on here? Let's make it sure. 47, 43. Okay. I can maybe just check this one out real quick, and then we can go to the podcast there. Okay. Or go to the one there. Alrighty. Okay, 53 is what you want, and we will do 53. If you need me to do 43, just put it down below, and I'll do both. But you just need 53. We'll start with that one. Cool. Start with this one. All right. So this one says a survey will be conducted to examine the educational level of adults, heads of households in the U.S. Those that have one and do not have a high school diploma. The survey will be conducted using a telephone interview. Oh, Nelly. All right. That should be a little bit of a, there should be sirens going off with that. Random digit dialing will be used to select the sample. For this survey, state one potential source of bias. Describe how the effect of the estimate of the proportion heads of households who do not have that's a key, who do not have a high school diploma. All right, so I would say on part A, and I would write a sentence about this, I would just say one potential form of bias would be what we call undercoverage, since individuals who do not have telephones would not be represented. And by the way, this is one answer. Some of you may put a different answer, and that's okay. And then it says, inscribe how it might affect. So I did this one. How could it affect? And I would just put down here, those that don't have telephones would tend to lean maybe more towards the side that do not have a high school diploma. Or you could make an argument for really either, because I know telephones, it's like who has a telephone now? Cell phones, yes, but telephones, well, random digit dialing. I guess you could say that this is a cell phone. This is an older problem, isn't it? I would say that as long as you put a little evidence with this of saying it would skew the data more towards the like higher or the lower side of those who have high school diplomas, or even the higher, depending upon how you approach that. But just make sure you put a little statement on that, identifying how that could skew the data, and then provide evidence from that. Part B, a pilot survey indicated that about 22% of the population of adult heads of house do not have a high school diploma. Okay? Do not. All right? So then it says, using this information, how many respondents should be attained if the goal of the survey is to estimate the proportion of the population who do not have a high school diploma within 0.03 at a 95% confidence interval. Well, this is where we want to say, okay, this is our margin of error, and that is equal to our z star times square root of p hat times 1 minus p hat divided by little n. The margin of error, they said, was within 0.03, and since it's a 95% confidence, we'll use 1.96. That's there. The 22% of the population of adult heads of houses do not have one. Therefore, since they gave this to us, we're going to put 0.22 in for our p hat. Okay, so we'll put that in. And we're looking for what the sample size is of little n. So this is where, again, we divide by 1.95, kind of like what we were doing earlier. Okay, so we'll do this, 0.03 divided by 1.96. All right, we'll square this value, and then we'll take, let's see right here. So once I divide it and square it, I get 2.34 times 10 to the negative fourth equals 0.22 times 0.78. And I get equals 0.1716 divided by little n. You could flip-flop these. So just put n on this side, this over this. Gets me divided by see, divided by, here we go, 0.000234. All right, just plugging that in. All right, so then I get 732.47, which I just would say is 733. So the sample size, and I might even say something like the sample size would have to be 733 in order to have a margin of error of 0.03 for the proportion and confidence interval that were selected. Cool. Your evidence, your explanation really is this justification, plugging in the formula, plugging values in, and then getting it out. Part C, since education is largely the responsibility of each state, the agency wants to be sure that estimates are available for each state as well as for the nation. Identify a sampling method that will achieve this additional goal and briefly describe a way to select the survey sample using the method. Identify, since education is largely the responsibility of each state, the agency wants to be sure that estimates are available for each state as well as for the nation. Well, this is where maybe we could use what we call stratified here. And this is where you kind of have to go and explain this. Stratified means that each state would be responsible for selecting a random sample, okay? And so what happens here is we are able to compare from state to state, and then we could collect that information, and each state would have a representation of the population. Maybe you could say, and there's no wrong method, identify a sampling method that will achieve this additional goal and briefly describe a way to select the survey sample using this method. I would say that, and this is just me, I would use a stratified random sample where each state would select 10%, select a, maybe lower than that, 5% random sample, or maybe 10% from their specific population. And then we could compare the data from state to state. And then we can also compare as a nation collectively what was that percentage where each state is equally represented by percentage. The way we could select the survey sample would be, and this is important too, and I would write this out in a narrative, but I would randomly select 5% of my population by putting out a survey that will be sent via email. 5% of my population, but putting out a survey that will be sent via email to 5% of the population at random. And I'm kind of blabbering, but I'm just talking as I'm kind of writing here. The sample selected will be from a random number generator. You want to make sure you describe this. And then also maybe state up here that will be sent via email to 5% of the population at random. How will that be random? The sample selected will be from a random number generator where 5% of individuals will be selected. And then maybe just say something at the end that says, hey, we'll follow up via phone if, in fact, there is a non-response that's there. That might be a good idea. Just as a heads up, I want to kind of go back and just double check this on 53. I think that was a tough one that lasts a little bit. 2005, question 53. So let's look at that real quick. 2005 AP exam. Let's check that one out. I just want to check out the scoring rubric here. Scoring guidelines. see here. All right, it's correct. We needed to state that the states are the strata. That's important. I forgot to say that, but well, I kind of did just with not in my writing. And then a random sample is taken in each state. Okay, so we didn't actually have to go into as much depth as I went into, but how that would be graded is each state is the specific strata. We'll take a random sample from each state and then bring them together for the national park. Okay. Cool. I hope this is helpful. We're just kind of going through some problems here on that Q&A. Harry, you got that last one on 53. I didn't see any other ones that were out there. Do y'all have any other questions that are there on 8.2? Any questions at all? Just kind of waiting for a second. (8.2). What question was that, Lindsay? Looking back up. Let's see, 8.2. Ones where you had to create distributions. Number 27, I don't think that one, you could throw that one out. If that's it, then we could throw that one out there. Oh, this one? Okay. So let me just show this one. This one's a good one. Clear objects. And clear that right there. Okay. So within this one, not that one. Sorry. Not that one either. This one. Okay, so when we're creating this is just a review. What they have is the hours that are here. So like hours and the number of accidents. These aren't two separate ones. I thought it was at first. It's actually, these all go together. So this would be like our first variable, and this is our second variable. All right, the A says, construct a plot that displays the distribution of the number of accidents effectively, okay? Construct a plot that displays the distribution of the number of accidents effectively. So we're not even bringing hours into play. We're just talking about number of accidents. So this is a one variable focus, okay? Number 2, or B, construct a plot that shows the relationship between the two variables, number of accidents and when they occurred. This has everything to do with two variables, okay? All right, so in a one variable, we have a couple of options. You can do a plot by doing a box plot. So you actually have to plug that into one variable statistics. You could also do this by going to a, you could do like a histogram. Okay, you could do that where, you know, like you got this is from here to here. This is how many. This would be like frequency, and then you have different ranges, and then you just plot it, right? Over here on the two variable side, this would be like L1, L2, where this would be X, this would be Y. This would be more of like a linear regression. So where you would take into account, do number of hours explain the number of accidents. So that would be the line that's here, okay? That kind of fits in between. So that would be the plot, the relationship between the number of accidents and the time when they occurred. As far as seed goes, it says describe something that plot in part A tells you about the data that the plot in part B does not. In this, we know that part A, when we're looking at this here, is like, what does it tell us? This is where you could go into like SOX a little bit and just go into what does the shape and outlier, center, and spread look like, that maybe you don't see like the shape or the center or the spread as much over here, okay? Whereas the linear regression talks about relationship. It talks about this idea of, remember little r, which is correlation. And we're able to see how tight or how spread out the data is in terms of the relationship that's here. But the key with this is you're able to use a relationship after you look at part B, okay? All righty. Hey, I hope this was helpful for today. I really do. I hope that we went through a lot of problems that maybe you had questions on. If you have any further questions at all, go ahead and email me today. I'm going to check out my email here in a second. But I hope that was helpful. We'll see y'all. Have a great day.